Hello, in this video, I'm going to show you how to calculate a confidence interval for a single mean using an Excel calculator developed for this course in statistics. There's a new diet plan that claims you can lose an average of 10 pounds in 30 days. Now, that just sounds too good to be true. So you and your friends decide to test it out. You get 19 of you together, so 20 including yourself. You all try out the diet plan for 30 days and find an average weight loss of 8 pounds with a standard deviation of 1.5 pounds. What is a 95% confidence interval for the average weight loss using this plan? First things we need to check are the assumptions for creating such an interval. All samples should be a random sample. Those have the best chance of being unbiased and truly representing the population. This sample is a little suspicious because it's a convenient sample of friends. Friends could be associating together because of their preference for diet and exercise. This sample leaves some to be desired. Let's continue on. Next, our sample needs to be either big enough or come from a population that's normally distributed. The rule of thumb we use for a big enough sample condition is n greater than or equal to 30. Our sample size is a bit small for that, but there's another condition that can be met to get the behavior of normal bell-curved sampling distribution, and that would be the population is already normally distributed. And it looks like we do have some suggestion that yes, the population came from something that's bell-shaped. Next, we will calculate the interval. Here we have the calculator developed by my colleague. In this calculator, you change values that are green, and the bold values below are your results. So our sample mean, X bar, for this example was 8 pounds. Standard deviation for the sample, 1.5 pounds. Sample size, 20. The claimed value, they claimed it was going to be 10. And we'll be doing a 95% confidence, so alpha is 5%. Together, the confidence level and the alpha make 100%. Our results below. Degrees of freedom, this comes from using the t-test statistic is n-1. If you click on these values, it will show you the formulas that are being used to calculate. So you can see the inner workings of the software here. I like this about Excel, that you can click on things and really see the formulas that are happening. So the standard error for a single sample mean is the standard deviation of the sample divided by square root of n. The larger our sample size, the less variation in the sampling distribution. Test statistic, if we were doing a t-test, this would be useful. So the test statistic p-values are useful for a test, but we're going to focus on the confidence interval. I really want to know how much weight did we actually lose. So the margin of error is the vital part to create this confidence interval. All confidence intervals are of the pattern point estimate plus minus margin of error. So here, point estimate is our sample mean, 8. Then margin of error, the ME, we'll get it from right here, equals 0.7. To find the lower bound, the lower limit of the confidence interval, you take point estimate minus margin of error, point estimate minus margin of error, and the upper bound is the point estimate plus margin of error. Given the sample we took, the reasonable range for the weight loss is between 7.3 pounds and 8.7 pounds. That does fall well shy of the claimed average of 10. We'll summarize our results by saying, I am 95% confident that the average weight loss on this plan is between 7.3 pounds and 8.7 pounds. This falls well below the claim of 10-pound average weight loss. I hope this video helped you to understand confidence intervals a little better and see one way you can calculate them yourself in the situation of a single mean. Happy studies!